Welcome back. This is an ALEKS homework video on solving a polyprotic acid equilibrium composition problem. Kind of a tough problem here because you've got lots of steps here. This is a multi-step mechanism, and so each one of the steps are going to have their own K sub A, and it's going to make its products on its own rate. And so this is actually kind of tough. This would scare me. I had to really concentrate as I did it to see what they were asking for. I tell you, the work you do though would really benefit you if you can do this well. All right, so let's look what they're asking. They've given you a phosphoric acid, which is a triprotic acid. You see there's three H's there, H3PO4. So when it breaks down, it's going to break down 3 times. It's going to give away 1 proton and then become H2PO4, which is -1. Then it's going to give away a second one, which becomes HPO4 -2. Then it's going to give its third one away and become phosphate ion, PO4 -3. So since it's in 3 steps, it has 3 K sub A's. It also, look at the data table because it says check the ALEKS data resource. They don't give you the K sub A's of this. They're going to give you the pK sub A's and make you do the work. Okay, so here's the pK of A of those 3 steps, and I reminded myself that the K sub A is 10 to the negative pKa. That's how you find the K sub A. All right, so that gives me the 3 K sub A's. The 3 K sub A's are basically the rate at which the products are being made. Okay, and I look at the first one and see that it's actually a lot larger than the other 2. So since it's a lot larger, then essentially the first K sub A is the rate determining step. It's the one that is going to product the most. So I wrote them down. So here's the 3 steps, and then I circled the one that I'm trying to find. I'm trying to find HPO4 -2, and I'm trying to find its concentration. All right, so how do I start? You start with the equation of the first one, because I have to find the concentration of H2PO4 in order to put that concentration in the second one so that I can find the HPO4 too. So I have to do the step 1 first. So I just wrote down the K sub A of that, and there's the equation of it. And then I did an ice table. Okay, so when you do an ice table, you're finding out what's going away and what's being made. So I just did an ice table. And I always fudge my x. Okay, so I hate doing quadratic equations. So I always fudge my x and just say, instead of 0.24 minus x on the bottom, let's just assume that x is very, very, very small. And if x is very, very small, assume it goes to almost nothing, then I can simply not do a quadratic and just do a regular Algebra 1 problem, and I got my x. But I got my x as 0.40747. That's actually 0.4. Well, that's bad. All right, here's the problem. It's too big of a number. Okay, if your x is really, really, really small, then you can get away with not doing the quadratic formula. But it has to be less than 10,000. Okay, less than 10,000. So since I've got a 0.040747, okay, that's really, really big compared to what it must be for me to not fudge it. So I had to do this again. I cursed it and did it again and did the quadratic. So I went to all the trouble of doing the quadratic, and I got my new x. So my new x is 0.037437. Okay, and this is the molarity of the H2. This is the first product. This is the molarity of the first product that's needed. So I had to do a second ice table. Now, in the first step, I found the concentration of my H2PO4, and that was one of the products, and the hydronium was the product, so I put that there. Now, in the second ice table, I have to find X. If I can find X, then I've got the concentration of the HPO4 negative 2, and that's what I'm after, so I'm trying to find X. So I'm going to do it again, and I sure don't want to do another quadratic. I hope I don't have to. All right, so when you do the ice table, this is how you proceed. And I look, and X is 6.166 times 10 to the negative 8, and that's way less than 10 to the negative 4. That means it's small enough that I don't have to worry about it. I just fudged it. Do you see? I simply divided by 0.3743, and I didn't worry about doing a quadratic formula. When I check my X, as long as it's small enough, I get away with it. So I always try this first. Then if it's too big, then I go back and do a quadratic, because I hate quadratic formula. All right, so when I find my X, I'm done. This is the molarity of HPO4 negative 2. And so the answer in 2 significant digits is 6.2 times 10 to the negative 8 molar. Okay, so to recap, this had multi-steps. You have to find your pKa's, change them into K sub A's in each step. Then you have to do an ice table for the first step, and in this case, to the second step, trying to find X. Always check, I never do quadratic if I don't have to, but if it's too big, then I do have to do it. And you just plug and chug. This is a long problem. This took me 15 or 20 minutes just to do the problem. So I wish you very well, and I hope this helped you.